Okay, so today we're doing the rest of Chapter 3, or Chapter 11, I guess. Section 3 is on difference of proportions. So sections 1 and 2 were difference of mean, independent, and dependent samples. Today we're doing difference of proportion. For proportion, there's only one formula. There's only independent samples. You don't do matched pairs for proportion. So this is the example on page 29 or 27 or whatever. 29. It says, during the 1980s, approximately 22 physicians over the age of 40 volunteered to participate in a long-term health study for which one important question was to determine whether aspirin alters the rate of heart attacks. The physicians were randomly assigned to the aspirin or placebo group. The results below are for a specific subgroup of the volunteers, specifically the men aged 50 to 59. So then it gives you your two groups, aspirin and placebo, heart attacks versus non-heart attacks. Determine whether there was a significant difference in the heart attack rates for the two groups. First of all, is it asking us for a hypothesis test or a confidence interval? Hypothesis test, because it's asking, is there evidence of something? Second of all, how do you know that it's proportion and not mean?
Heart attack rates.
Rates. The word rates implies proportion. Okay, so like before, is it okay if I just do the stuff that's different rather than doing the entire hypothesis test? By now, do you guys get the idea of a hypothesis test down? You're just staring at me. Nod.
Is this being recorded?
Yes. When I said nod, like two of you nodded. Yeah, Miss Button, we're good. You would just need to know the new stuff.
I'm sorry, though.
Good, thank you. Okay, if we do the entire Phantoms, then you're going to have to stay late. You still want me to do the entire Phantoms? Okay, that's what I thought. Okay, because it's proportion, now we're going to use pi and not mu. So you're going to have pi 1 and pi 2. So pi 1, let's say, is the population proportion of heart attacks. Make sure you use the word proportion, not rate. And I'm going to say in the aspirin group, because that's the one that came first. Pi 2 then is the same thing except the placebo group instead of the aspirin group. Next is H. Your null and your alternative are going to be pretty similar, except instead of mu 1 minus mu 2, you're going to have pi 1 minus pi 2. 99% of the time, that's going to equal 0. And then we want to know, is there a difference? It doesn't tell us which way that difference goes, so we're testing not equal to 0. You still have to tell me what this means in words. So our null in words tells us that there is generally no difference in the heart attack rates for the two groups, versus yes, there is a difference in the heart attack rates for the two groups. Your assumptions. I told you there's no matched pairs for proportion. So the first assumption is always going to be, do I have independent random samples? Okay, one thing that I want to talk about that a lot of you mixed up on your quiz, when it says random sample, that is not saying randomized. Do we recognize that random sample and randomizing are two different ideas? What does a random sample mean?
Sample was randomly picked from proportion.
Not from proportion, from
Population.
from the population. You took your population and you randomly chose who's going to be part of your experiment. What does randomized mean?
The treatment was randomized.
How you determine who gets what treatment. Is that clear, the difference? Because when you write randomized, that's wrong. You're checking for a random sample. What do you guys think the second assumption is? Approximately normal. Sampling. What's
Distribution.
distributions? Yeah. Okay, we have two variables, pi1, pi2, so we have to check for two sampling distributions. not 1. Okay, this one is kind of a pain. You have to check N1, P1 greater than or equal to 10. You have to check N1, 1 minus P1 greater than or equal to 10. That's for the first sample. Second sample is going to be the same thing, except N2, P2. Okay, so in our case, for this aspirin group, P1 is going to be 51 people had a heart attack out of the sample size is 3,725.
Why is the N2 ones greater than or equal to 0?
It should be 10. Thank you. So our placebo P2 is going to be 87 people who had a heart attack out of 3,725. In this case, our two samples are the same size, but generally that's not going to be the case. Do you guys think that you could check this on your own? Yes? Okay. Again, you have to make sure that you check for both, that you speak in plural. If you don't speak in plural, I'm not going to accept it. This is the only way to check. So it's not like with mean where you had the box plots or the population's normal or the central limit theorem. It's just this. That's it.
Where did you get the denominator from?
From adding these numbers together and those numbers together. Can I keep going? Yes? Okay. N is pretty much the same. Oh, that. First thing that changes though is obviously the name. It's going to be called a 2-sample hypothesis test for the difference in population proportions. Other thing that's going to change is the table that you use for proportion. What table are you going to use? Standard normal. Proportion is always Z, which is the standard normal table. Please don't call it the Z critical values table. No such table. Okay, you made that up. Okay, so does this seem too bad? Okay. It's all fun and games until you get to the T. Build up the suspense. Ms. Bond, you made a mistake. What is this C thing? It's another formula. This is not a joke.
It's so much math.
Megan?
But isn't that a PC thing only for like when it's equal to 0 or no? I feel like they said something like that before.
I will check, but regardless of what they said, we use it all the time. They did say something about 0, but not what you're thinking.
Okay.
Okay, you guys ready? Woo. Okay. Our P1 was 51 out of 3,725. Then I'm going to multiply that by 3,725. This is all to find PC. Plus 87 out of 3,725 times 3,725. All over. Both sample sizes are 3,725. Now, these denominators cancel. These denominators cancel. It ends up simplifying to 69 out of 3,725. Now to find z. Can I keep going? Megan, what do you not believe me on?
The bottom,
Why?
isn't it? It's 2. Oh wait, no. Okay. Yes.
You still don't believe me. What do you not believe me
No,
on?
it's okay.
Okay. Heather?
Why aren't you adding them together? Like, why?
I did, but once you add those two, there's a common factor of 2. So I just simplified it. Was that what you didn't see?
Yeah.
Simplifying. Yeah, I simplified so that I don't have to deal with as bad of numbers. Okay. P1 was 51 out of 3725 minus 87 out of 3725 minus 0 because that was in your null. Then in this denominator, you have 69 out of 3725 times 1 minus 69 out of 3725 out of 3725 plus, same thing over again,
How much work are you wanting us to show?
all of this.
Can't you just like put, if you say like PC equals 69 over 3725, can't you just put PC?
Oh, true.
No.
Isn't there some more efficient way?
Write this? No.
Are we
Good
gonna
talk.
find like another chapter?
What?
Are we
Is
gonna
there
find
some way
more
you
efficient-
actually-
There is no quick way to do this.
Somebody's
why
gotta
is it
cancel out.
done?
This is the only way.
I don't think so.
Yeah, Heather?
How are we gonna be able to fit all of this onto one piece of paper when we're testing?
It's lucky for you that more than one piece of paper exists in this world.
Thank you.
I will give you another piece of paper.
Thank you.
Now, based on last class and just my own knowledge of your calculating abilities, I am not
That was
convinced
my fault.
that we can all get the correct answer here. So right now, take out your calculator and see if you get the correct z value.
Someone make, what if someone makes a program for us?
What?
Someone make a program for us.
I feel like
I
I'm
got
gonna type it all in and it's gonna say error. Okay.
Let's throw out my savings.
I would love to see an answer when you have one. So just let me know.
Give me like 10 minutes. I know you're messing
I
too.
need programs.
We have one person with the correct answer, so it's possible.
Already?
Max, is that you?
Who, me? No, I can't. I'm no calculator whiz.
Wait. No.
I think I'm missing parentheses.
Still only have one with the correct answer.
I think I'm
What
gonna
the
get.
hell is it?
I'm definitely getting an error on this.
Does that seem reasonable? Negative 15,000.
Hey,
What are you doing?
they wasted your time. That's
Negative
what
15,347.
Wait, I didn't like the
I'm
answer.
losing track of my correct.
Oh, I get error. Then you did something wrong.
I added so many random parentheses that I can't tell.
Yes.
Wait.
I'm not graduating.
Taylor, shut up, man.
I got it.
Okay, stop. It should be negative 3.0933.
I want the.
There are like 10 of you maybe that got it. If you got it, make sure the person next to you got it. And if they didn't, help them.
We got it. So
Dude, you're the nice calculator. She's a nice calculator. Who has a bad one?
Oh,
Did you get
Oh.
Can you show me how?
Oh, wait, you didn't PC that, but.
Yeah, I stored PC and
Oh,
then
then you
typed it back in.
Oh, yeah, yeah.
I should, but like.
See, I swear to
Nobody sees me so much.
Yo, what was it?
Yeah, no.
Negative 3.0933. Okay, please tell me that we used our calculator efficiently and that we stored PC as X.
I stored it.
Oh my gosh.
Why didn't you tell us before?
I thought we knew how to use the calculator. Obviously, that's a four.
Literally, I wanted to make it on my own. I got 20.
That's like the first week.
Because when I walked by your house yesterday, on
Okay,
my way to Lincoln.
regardless of where you're at, just stop talking. This is what you should have gotten. If you didn't, you need to go home and practice your calculator skills,
I
okay?
should do that.
Okay, so let's think of what we're looking at. If we draw a normal curve, we got this negative 3.09, and we did a two-tailed test. So you're going to have to do the lower tail, and then you're going to have to do the upper tail also. Of course, they're symmetric, so you really only have to find one of them. So we're going to find the probability that z is less than or equal to negative 3.0933. That's the lower tail, and then we're going to multiply by 2. Okay, so that's going to be normal CDF of negative 1 times 10 to the 99th. That's our lower bound. Our upper bound is negative 3.0933, but of course use the actual answer, like second answer or something. Because it's a z-score, the mean is 0 and the standard deviation is 1. Once you get that and you multiply it by 2, I think it should be 0.00198.
Is the standard deviation that whole, is there any way we like know that other than we calculate?
Yeah, you still have to double label, so the standard deviation is going to come from the entire denominator. Okay? Got it?
At the square root of 2.
Okay. The process is not that different, it's just extremely tedious, yes?
Correct.
Okay. Can we go back to something I forgot to tell you about?
No,
No? Okay, we're going to do it anyway, so don't really know why I asked.
I said, oh.
Oh. Okay. Do you guys remember that when we checked this assumption for one proportion, that we did n pi greater than or equal to 10?
Yeah.
I want you guys to remember that. So if it's one sample, we do n pi, but for two samples, it's np. That's because here we don't really have a value for pi 1 and a value for pi 2.
So for like matched pairs, we'll do pi instead.
Matched pairs, there's no matched pairs for proportion.
Can you repeat that really fast?
Uh-huh. So if it's one sample test for proportion, you do n pi greater than or equal to 10, and 1 minus pi. Here we don't have values though for pi 1 and pi 2. We don't even have estimates for them, so that's why we use p.
Do we not use the n is less than 0.1 big N?
You don't have to do that here.
When is that used?
One sample. There's one sample do that?
phantom?
One sample both.
But only for proportion.
And me.
And
Anytime you do one sample panic or phantoms, you have to do it. Other than that, you don't have to. Okay. Going back to what we just did, based on this p-value, are we going to reject or fail to reject? Reject. What does that tell us about the difference in heart attack rates for the two groups?
It's not significant. There's no significant difference.
Too rare to attribute to random.
Okay, just stop. Oh my gosh. Okay.
Not
Do we reject or fail to reject?
reject.
Do we believe that there's a difference in the heart attack rates?
Yes.
Yes. That's it, period.
Wait, we don't have to do.
Now, you have to still have to do the second sentence. But when I ask you, what does it mean? I don't want you to jump into it. It means that it's too random to attribute it. That's not what I want. Just generally what it means, if someone asks you, what did this study tell us? It told us that we believe there's a difference in the heart attack rates. Do we know what that difference is? No. It leaves open the possibility that the aspirin group had a higher heart attack rate. We don't know what the difference is, we just believe that there is a difference of some type. Questions on the phantoms? Do you think you guys can fill in everything else? Like at home, do you think you'll be able to write a conclusion and all that since really nothing else changed? Do you want the good news?
Yes.
There's no panic.
What?
Are we at period 7 somewhere?
Yeah, you're pretty close. Pretty close. That was not the good news.
Oh.
The good news is that panic does not use PC.
Woo!
Thank you. Yeah!
We love AP stats and we don't care.
What is the significance of
Okay, guys, we're going to write down the formula and then I'm going to answer that question. Okay, formula for panic is P1 minus P2 plus or minus Z. Write this down somewhere. I don't care where. Write it down. We're not actually going to carry it out. Just write it down. No PC. That was funny. Yes.
Are panic and phantoms like a nationwide thing, like how people learn, or like, did you make these up?
They are very common.
I talked to a guy from Mundelein and he said they use pants or something for panic. But they use phantoms too.
That's ridiculous.
They use pants.
Yeah, I would guess probably 75% of people call it panic or phantoms. Okay. So somebody asked, or Matt asked the question, why use that PC? Do you guys know what this quantity is? Everything under the square root? Standard deviation of
The total.
the sampling distribution? Sampling distribution, right? So this is the standard deviation of the sampling distribution. The reason that we use PC for phantoms is because we think that using PC gives us a better estimate of the standard deviation of the sampling distribution. That's why. It's a better estimate.
Well, even better.
You do that.
I will.
Okay, because this is so tedious, it is very easy to make a mistake, and I want to make sure that you guys know how to check your answer. So I have a feeling that all those times I showed you how to check your answer on the calculator, you didn't do it. But maybe this time you're going to pay attention. I know. Okay, do we all have a calculator out?
Proportion C.
Okay, you can probably guess that you have to go to stat, and we're doing a test. I told you that proportion is always going to say proportion. So go to a 2 proportion Z test. This is what you need to enter. 51 people had a heart attack out of 3,725. 87 had a heart attack out of 3,725, and you get not equal to. We'll do draw first, just for fun.
Wow.
In the bottom, you're going to notice they got the same z-score that we did and the same p-value. Yeah, did you guys get that?
Sounds like jumbo.
But I have 2 lines in mine.
Because you have something in y equals. I'm going to do the same thing, but hit calculate this time and see if it gives us any additional information. Okay, this didn't really help us at all, so. Okay, now if you go to stat and you go to tests, now to do the confidence interval, it's going to say 2 proportion, but it's going to say interval instead. So on mine it's B. The same information should be there. Let's do a 95% confidence interval. And if you hit calculate, here is the confidence interval that it gives us. Based on this interval, do you think that there's a significant difference in the heart attack rates?
Yes.
So it's basically the second question on your, or the last question on your quiz yesterday. Is there a difference in the heart attack rates? Yes. Why?
Because there's no zero.
Because 0 is not in the interval, and 0 would indicate
No change.
the possibility of no change, right? A lot of you guys, I think, looked at this, you're like, well, it's really close to 0. I'm not asking how big is the difference. I'm asking, is there a difference? So yes, there is a difference. Does it look like it's very significant? This would be a difference of 1.5%. This is a difference of 0.3%. So yes, there is a difference. It doesn't look like it's very significant, though.
Is this a real study?
I believe so, yes. Yes. I actually just read